Hello everybody, how you doing? This is MrDoTheMath here, and today I want to talk to you guys about transformations, but not just any type of transformation, translations. If anybody's taking geometry, you know, or if you're taking geometry, there are four basic types of transformations. You have a translation, which is a slide. You have a dilation, which is when the figure or the image expands or contracts, so it gets bigger or it shrinks. You have a reflection, which is when it turns around, basically. Turns around about an axis, or rotation, where it flips, okay? Today what we're going to look at is translations, right? Translation, again, is a slide. And there are a few vocabulary words that you need to know about, all right? So one of them is this. You have two images. You have a pre-image, and you have an image. And here's the situation. Translations, you're moving figures, shapes, right? Shapes like a triangle, a quadrilateral, things of that nature, right? And so the first image is known as the pre-image, right? And the pre-image's points or vertices are represented by just letters, right? The image is the second or the end point of the original image, right? So if I have a triangle, which would be A, B, and C, and it moves or it slides, it's going to translate to be an image. Pre-image is the old image now. The new image is called the image. And his vertices are known as A prime, B prime, and C prime. So anytime you see this mark here, it's referring to the second point. Or the second figure, right? The new figure, right? Image is new, pre is old, right? Old, new, right? So, what makes it a translation what makes it a translation is the fact that nothing else changes in the figure except its position, right? And so, because only its position changes, which means it moves from one point to the other point, it is known as an isometry, right? That's the real special, real big word that you're dealing with here, right? It's isometry. It's isometry because the size doesn't change and its angles don't change. It just stays the same. So this triangle would just slide from here to here, right? Isometry. All right, we got this box here. This box moves from this point to this point. It just translated, all right? And because nothing else changed about this box, it is known as an isometry, all right? Now let's talk about some rules of translation, right? Again, the only thing it changes is its position. So it moves either up and down in relation to the coordinate plane, or from left to right, or diagonal. So it just moves up and down this way, or this way. That's the only way it moves, right? Okay, so the movement, they tell you it moves based on its notation. So the first thing they'll say is X and Y, which is talking about a point or vertice, translates to a new place. So for instance, if we had X plus 3 and Y minus 1, what this is saying is that the pre-image is going to move 3 places positive on the x-axis. So that's going to be 3 places to the right, and 1 space negative in the y direction. So that's 1 space down, right? And so there's several ways that you can work this out to make it simpler for you. You can substitute in the pre-image x here and do the math here. Substitute the y image here, the y value here, and do the math here. All right? And then you find your image's new place. All right? So for instance, let's use these points. If A is located at negative 1, 2, B is located at negative 1, 5, and C is located at 4, 6, we can figure out its new places if it translates, this image's new place if it translates x plus 3, y minus 1, right? By just simply substituting, okay? So the first thing we're going to do is we're going to take the x value, 1, all right? So the image is moving x plus 3, y minus 1. So it'll be negative 1, that's his x, plus 3, right? Plus 3. And for the y, it's going to be 2 minus 1. Alright? Therefore, -1 plus 3 is going to give us 2, and 2 minus 1 is going to give us 1. So, the image's new vertex for A will be 2, 1. Do the same thing for all the other points. So again, this x is at -1 plus 3, right? 1 plus 3, -1 plus 3 is 2. And then you have 5 minus 1. Minus 1. It went down one space, so it'll be 4. And then for C, it's positive 4 plus 3. So it went from 4, and it moves 3 places to the right. So it'll be 7. And then you got 6, and it moved 1 place down, 5. So now, the new location of this image, when it slides 3 spaces to the right and 1 space down, would be A prime would be 2, 1, B prime would be 2, 4, and C prime would be 7, 5. Okay? That's how your image moves. And you just follow this notation here. Okay? They also represent this kind of notation as a vector quality as well. Remember we said, okay, I'm sorry, let me write this down again. Yeah, y translates x plus 3, y minus 1, right? They use a different notation called vector notation. And what the vector notation is simply doing is, it's basically going to follow this point here, and it's going to tell you again, it slides 3. It's going to go 3 to the positive direction of the x, and negative is going to go 1 down, or negative in the y direction, right? 1 space down. And it'll be something like this, and we can say A, like A moves like this. A glides like this. So if it were here, it would glide, if it's -1, 2, it would glide like 3 over. 1, 2, 3, which is where the 2 is, right? And then it'll go 1 down. Bam. This would be the new place for A, right? And that's where you get your 2, 1 at, right? The same thing for B. You know, it'll go 3 spaces over, 1, 2, 3, and then 1 space down from 5. Bam. And that's how you get your 2, 4. 3 spaces over from 4, 5, 6, 7, and then 1 space down. 5, 7, 5. Okay? And pretty much that's how you translate. Translations are slides. They're also known as slides, right? And this is pretty much it. You take the notation, substitute in your pre-images points here, do the math, and you end up with the new image's location. Alright? And Mr. Do the Math out. Please remember to like and subscribe below.